What's going on, guys? Welcome to Bitcoin and Beyond. Today we're going to be talking about zero trust protocols with Omar. Omar is part of dWallet, and dWallet is building these zero trust protocols for applications on Bitcoin. Omar, welcome.
Thank you so much, Ruby. Great to talk with you today.
Likewise. Let's dive in.
Okay, so first of all, I think maybe we can start talking about the team. And also, we'll get into the concept, what it means. But in general, we enable zero trust protocols. It's something that is very important. It comes from cybersecurity. And this is also our background. So we are the founders. We're coming from cybersecurity background. We have been to intelligence core before in cybersecurity companies, also from the cryptographic side. So we have also people from the academy on the team. We have today on the team over a dozen of cryptographers and cybersecurity experts, and this is really the focus. And what we wanted to do is to bring this new concept of zero trust protocols, which is something that really changed since Bitcoin started, with crypto started with Bitcoin. And we had that security assumption of zero trust. And along the way, because we needed to innovate and we needed to bring new capabilities, we had to change to different type of security models in order to enable stuff. But at the same time, we had to reduce the security assumptions that we had before. So this is really the goal. This is really what we try to solve. And I'll start with talking about what it is, right? What is zero trust, why it's important, why we need it. So in Web 2 cybersecurity, it comes from Web 2 cybersecurity. And also we have that in crypto, in Web 3. But the concept says that we have two different security models. One is called castle and moat. And it means that we have a security parameter, that this is the moat, this is what secures the castle, right? But if we get into the castle, then we get access to everything. We can do whatever we want. And this is, by the way, how companies in Web 2, in high-tech, right, started. They started with these castle and moat concepts. But during the time, the space, the ecosystem started to understand, like from the security perspective, that it's not good enough. And we need a better solution. We need a better way to change the trust assumptions that we have. And this is how this new concept of zero trust can. The concept of zero trust says that trust nothing, right? Don't have the same model where you have the castle and just you have to pass the moat. And if you're into the castle, you can do whatever you want. Let's have a different approach that every time that you want to do something, we need to verify you, right? We need to verify that you are really the user, you are really the person that make this action, and you should be able to do and to make that action. And we do that all the time, right? So the concept of zero trust is trust nothing, validate all the time. And then if we connect that to Web3, when we started with Web3, with crypto, Bitcoin, Ethereum, we had zero trust by design, okay? It means that everything that we have done before was using those assumptions. And I know that people in Web3 haven't been really talking about that, about this concept of zero trust, but this is actually the design that we have in Web3, like the initial design, the way that we started. So what I mean by that, let's give you an example, right? Let's try to connect that to Web3. So we said that in Web3, what we have, Bitcoin, Ethereum, chains, they are zero trust architecture. This is the model. So just to let you understand what it means, let's just imagine for a second that we have a different universe. And in that universe, instead of Ethereum, we have a Caselium, right? Which is the castle and moat version of Ethereum. So what's the difference, right? How it will look like, how Ethereum will operate in this scenario. So the difference is that in Castleum, what we have is that we have the castle, the blockchain state, right? So the state of the blockchain is what we really look at, right? And this is what people or users will try to change, to manipulate, or whatever they do, whatever action that you do in a blockchain, right? At the end of the day, really change the state. And in that case, what it means is that the validators will agree what is the state, right? They will say that, for example, Andy, you have 5 coins, right? But you have no way to validate that, right? The only way that you have to validate is just to know that they sign on a block, you have the signatures of the validators, but maybe they lie. You have no way to understand that, to know that. And if I compare that to reality, to Ethereum and how Ethereum works, and it's very similar in other chains like Bitcoin or other Solana, other type of chains. Also, by the way, with the rollups and L2s, it's a bit different, the mechanism, but the concept is the same. We have users, they sign transactions, and those transactions are included inside blocks, right? And then the validators, they sign on the block, right? They don't just approve the state. They don't just tell us, that's the state, trust me, I'm telling you that's the right state. And you have 5 coins, trust me. The difference is that there are transactions, and those transactions, they are the way to change the state. So it means that everyone can calculate the state using those blocks. So anyone can run a full node, right? I can run my own full node with Ethereum. I can start from Genesis. I can calculate all the blocks. Every block then since Ethereum started or Bitcoin started. And I can by myself calculate the state of today, the current state. When I do that, what actually it does is to verify every transaction and to verify that every transaction is valid and is corresponding to the public key of the user, right? So for example, if you transfer to me coins, there is a transaction in one of the block and I can verify that, right? I don't have to trust the validator that you really have this amount of coins. I can do it myself. I can validate myself. The only thing that we trust in the current model that we have in blockchain, specifically in proof of stake, but it's also in proof of work, is the set of transactions that we have in every block, right? So this is what I can play with, but I can't generate a transaction. There is no way for validators in Ethereum to create a transaction that you transfer coins to Ruby, right? You can't do that. But what they can actually do, they can censor you, which still keep the same security assumptions of zero trust. Okay, does it make sense? Okay, and the reason why I'm talking about it, why we're focusing on that part, is for you to understand what are the security assumptions that we started with, right? The zero trust, where we know that we can validate everything, we can verify any action of any user, every transaction, and we can do it cryptographically, right? So we know the identity of the wallet that made that transaction. But whenever we come to interoperability or multi-chain, or in general, where we have many networks and we live in a sovereign, different zones of sovereignty, right? In that case, we have a huge problem because it's really, really hard to apply the same module, the same security module, the same zero trust architecture in that case. And the reason why it's so hard is because now we have different states of different chains, and we don't have a way to make the connection between the two from the user perspective, right? So we always have to trust some third party. We need to trust like something of that state. And this is how we go to this castle and moat. And by the way, this is something that Vitalik talked about, right? And Vitalik talked about it specifically about cross-chain, right, versus multi-chain, which means that in cross-chain we have, for example, bridges, or we have other solutions where we represent the asset in other chain. But at the end of the day, what Vitalik is really talking about is zero trust compared to castle and moat, right? Because in that case, in those solutions that let us create new protocols that can interact in different chains, in different assets. In that case, it's almost impossible to do it in a way that is zero trust. And that's because the connection to the user, we don't have an easy way to verify every action, every transaction. So for example, if I'll just give you an example, we have WBTC, right? And if I use Uniswap with WBTC, so this is a very simple example to understand. We have to trust BitGo's, right, custody. Because WBTC, you have BitGo, they decide what's the state, right? And they can decide whatever they want. We have solutions that are more distributed or more decentralized, but still we have some castle that if we get into, we can change it to whatever we want, right? It can be centralized, it can be decentralized. But at the end of the day, in any of those cases, either if it's easy to do, right, to pass the moat, or very hard, if we get into the castle, we have a full control, we can do whatever we want.
Yeah, there's something to add there on the bridge stuff. I think that chain abstraction, there's this idea that kind of plays into this interoperability work. It kind of falls under the same umbrella where, it's almost like the weakest link security issue where you have, you as a user in a chain abstracted world or in a completely interoperable world. Yeah, I mean, there's a world where you end up using chains, without realizing, if you will, or at least not understanding what trust assumptions you're taking as a user.
Exactly, and I think this is part of the things that are missing today, and this is one of the first things that we want to make everybody in this space, to educate the space to understand, is this concept, right? So everybody knows what is zero trust. Everybody knows to try to evaluate a protocol if it's a zero trust protocol or it's a castle and moat protocol. And again, I'm not saying that if it's better or wrong, right? It's at the end of the day, it's really about your risk appetite, right? So if you really care about the ownership of your asset, right? If you're in this type of user, so yeah, bridge is not for you, right? Because if you use bridge, you take a different security assumptions than you have with native assets. And many people don't even know that. They think like they believe that it's the same. So here we have a few examples. By the way, we call it the Honeypot Problem because people say, like, for example, I have this protocol and it has been working for years and nothing really happened. That's great, right? But what it means that maybe the moat is hard to bypass, but it doesn't mean that it's impossible, right? That's one. Second of all, it means that maybe the honeypot is not big enough yet, right? So maybe the assets that I can steal are not enough that I have the incentive to try to steal them. Maybe in 2 years, when it will be 10x, 100x, then I will have the incentive, I will do that, right? And this incentive can be from hackers trying to steal the assets, and it can be also from the collusion of the participants of the network, right? They can say, like, the token or the assets or what we get from being validator is worth X, and to steal the asset will be 1,000,000X, right? So let's steal the assets, right? So it's really, really hard to try to use that argument because it just means that we're not yet into this phase where it's worth it, right? We don't have the right incentive, but it doesn't mean that it's impossible. And this is, I think, the confusion that many users have, right? They don't really distinguish between the two, right? You have some things that you say, it's been working for years, I can trust the security because probably if we had some vulnerability, somebody would find it. But the incentive side is very different because it also depends on what you have, what's the honeypot, what I can do with that, what I can steal. So we have example of Thorchain, right? Thorchain is a great example of, by the way, I think it's a really good protocol. It's a really good solution, but it's a castle and moat protocol. And the reason is because, and by the way, they have MPC, and I know that people believe that if it's MPC, then it's secure, and that's correct. We also use MPC. We use it in a very different way to be zero trust, but it doesn't mean that you are automatically zero trust, right? Just mean that probably the moat is harder to pass, right? It's stronger, the security that we have, but it doesn't mean that it's impossible to pass that. So with Thorchain, for example, we have those vaults of nodes, right? They have, I think, around 100 validators, something like that. And they split them between different vaults. And each vault can access certain assets, right? And what it means is that this vault, every vault, is a castle, right? So it might be hard to get to that vault, right? Maybe I need to hack 20 nodes and to steal their, not even, probably it's not 20 because usually you have a threshold. So let's say that I need 2/3, right? So I need, let's say, 13, 14 validators, and then I can steal the vault. Or those validators, they can collude and together decide that they want to steal the vote because the vote worth more than their assets and more than everything that they do, right? So this is a great example of protocol that it's great protocol, it's super useful, but the security assumption is very, very different than using native assets, right? Yeah. So that's one example. Second example is, for example, Camino. It's in Solana, and here, actually, what we wanted to demonstrate is that you have sometimes native protocols like swapping or lending, like Uniswap. Those that they can be on Solana or they can be on Ethereum. And at first look, you might say it's zero trust, right? Because it's on Ethereum and Ethereum is zero trust. So I can trust the protocol, which is correct. But it's correct only while the assets that you trade in those protocols are also zero trust, and which means only if they are native assets. But once you use wrapped assets, then the old protocol stops being zero trust. It may be partially zero trust, right? But as a user, for you, it's not zero trust anymore. So it means that, for example, with Camino, you have WETH, which is the wrapped version of ETH on Solana. They are using wormhole, and then that's the castle, right? Those 18 wormhole guardians, they are the moat. If you get into and you control them, then you control the castle, you control all the assets on wormhole, and you can steal everything. Also, they can collude, right? So again, the security assumption is that you have to trust those 18 wormhole guardians, right? This is what you do whenever you use WETH on Solana. And even if you use it on a native protocol, that may seem like it's a zero trust protocol, right? A different example, which is Uniswap. And I think this is a great example because it's like one of the most amazing protocols that we have. Also on Ethereum, Ethereum is very secure, very decentralized. And in terms of the security assumptions, again, Ethereum is zero trust. We may think that Uniswap is always zero trust, but that's not completely correct. It's correct that whenever we use that with native assets is zero trust, but whenever we use that with WBTC, then we have to trust BitGo, and that's the moat. If we get into BitGo, we can steal the assets, right? If an employee at BitGo have access to the keys of WBTC, they can steal that BTC. So what we do whenever we use that solution is that we actually trust in BitGo. And it sounds very counterintuitive because you think about Uniswap as a very decentralized protocol, but whenever you have asset like WBTC, then immediately you are not really having the same security assumptions. And then we have more of the Bitcoin L2, right? which we have right now today many new Bitcoin L2s that come in with different solutions. So, for example, with Stacks, they have MPC. There is enforced, which is an MPC protocol for Schnorr signatures, and they try to create something that is clever and to secure, to create many small ways to increase the incentive to make it more secure, which is great, which is amazing. But again, it's not zero trust. And why it's not zero trust? Because we have to trust the nodes. They can collude. It might be harder to do that with Stacks than do it that with Thorchain, maybe, because they have more nodes. It's more decentralized, but we can do that, right? So again, it's not about how hard it is to get into the castle. It's either if we get into the castle, we get access to everything, right? So this is how we compare zero trust protocol to castle and moat protocol.
Would you say that Ethereum is castle and moat because it has a decentralized it has a decentralized set of validators, but if you're able to compromise the set of validators, then you get into the castle?
So actually, Ethereum is zero trust. It's not castle and moat. And Casilium, the example, the imaginary parallel universe blockchain, right? This is castle and moat, right? But it's not really exist. It was just an example to show how it can be. And the reason why, and this is, again, it's important, again, maybe we need to get back to it, is because the validators of Ethereum, they're not deciding the state. They're not saying this is the state, trust us. The way that you calculate the states is based on transactions from the users that you can validate all the time. So you can verify every transaction, and this is exactly the requirement of zero trust, right? We can verify all the time. Everyone can verify. So there is no way from the protocol perspective, right? If you follow the protocol, that somebody will be able to lie to you or cheat and say, I transferred to you assets without really having a transaction that I transferred the asset and I signed on it, right? No one else, on one of the blocks on Ethereum, right? If you don't have that, then it doesn't exist, right? So you can't just create it from thin air. And that's exactly the difference, right? What's the assumption? Who you should trust? So on Ethereum is zero trust because the user have to sign on transaction and everybody can validate and verify every transaction, right? And with all those solutions, all those examples, right, we don't have that security guarantee.
Okay. And there was one question that I had on this real world zero trust blockchain design. So in this case, this is Ethereum's case, right? This is a zero trust blockchain. And the last sentence, you say no one, not even the validator's consensus, is trusted. Everything must be verified. And so is that because users are running full nodes and it's permissionless to run a full node? I guess, could you kind of elaborate on how we're able to verify the validator's consensus and we don't just trust the validators to provide the next block in the chain?
Yeah, so that's exactly correct. So the way that we validate is by running full node, right? If you run full node yourself, no one can lie to you, right? Mm-hmm. You take what the full node does is to take every block, right? You have ways to make it faster, and then you have to trust somebody, and then you don't have to start from Genesis. But if you really want to trust no one, you can start from Genesis, and you can execute every block, and you can verify every transaction of every user since Genesis, right? So you know the state, and no one can lie. There is no way to lie, right? It's impossible. But in the example that we gave, right, you have to trust the validators because they tell you what's the state, right? You don't have, like in the imaginary examples, we don't have all the transactions in the block. We just have the state, right? What's the current state? And then you have to trust them saying the current state. Actually, if you want a good technology that we have today that uses this concept is light clients, right? Mm-hmm. Are you familiar with the light clients?
Yes.
So light clients, it's actually castle and moat because what we say is that look, to run a full node, it's costly, it's expensive, and it's not something that everyone can do. So let's find a better way to have some security assumptions over the state, right? Because today you get the data from a full node from somebody else, and they can lie to you, right? It's a super simple attack vector, right? You connect to a full node, the full node lie to you, and by that, the full nodes cause you to run transactions or to do stuff that the full node wanted, right? If it's not your full node. So the idea of a light client is that we have the validator signing on the current state, right? So it's not zero trust, but it's better than trusting one full node, right? So it's something in the middle. But this is an example for a castle and moat that we have today in many blockchains. It's not in any blockchain. It's the one that supports light clients, but we have that on Ethereum, for example, Solana, and many other chains. So what we have in blocks, we have both, right? We have the transactions, and also we have the usually it's the Merkle root. It's not like the full data of the state, but it's just the root of the tree of the full state. This is a way to know the full state, and they sign on that as part of the block, so you know what they agreed that is the right state. But still, you can also verify that yourself, right? You don't have to trust them, and this is the complete difference between the two. And if we go back to all of those examples, here you don't have that, right? There is no way for you to really verify, validate, to be involved. And whenever you do stuff between different chains, so you need somewhere that you have the state, and you need to trust on this place, right? So it might be in WBTC, so you trust BitGo, right, to say what's the state. Even if you have native bridges that sometimes people confuse, it's still castle and moat, because then one validator set in one blockchain, they decide what's the state in the other chain, right? So at the end of the day, you need a way to make sure that the users wanted to make actions in both chains together in an atomic way, which in most cases and in the most technologies that we have today seems at least as impossible. And this is also why we created dWallet network, and we started this new concept of bringing back zero trust to interoperability, to multi-chain, something that we don't have today in Web3. So what is zero trust protocols? Zero trust protocols is as the examples that we have here, but instead of using technologies that are not zero trust, and then the full protocol will be castle and moat, is to use solutions that they are zero trust, and by that you make sure that the full protocol is a zero trust protocol. So how we do that? We created a new building block, the first zero trust building block. We call it a dWallet. This is also why it's called a dWallet network. And it's a building block for builders, right? It's not something for the end user. It's not a solution for the end users to use. It's not like a wallet, right? People sometimes confuse between dWallet to a wallet. Those are different concepts. And the way that it works is that we created a new cryptography, a new technology. We're using MPC, but it's a new MPC protocol that we created from scratch. It's called 2PC MPC. And this is why we have this extensive team of cryptographers and cybersecurity experts. It took us almost 2 years to create that. But it's the first threshold DCDSA signature protocol, where it's first of all very decentralized and scalable. But from the other end, and this is the important part, and this is what makes it zero trust, the user is always required. So there is no way for the network to make a decision, right, to sign a transaction to any of those chains without the user. And even if all the validators on the dWallet network, if 100% of them collude or act or whatever, really, I'll take the most crazy scenario that probably is impossible in reality, still there is no way to steal the user assets. And why is that? It's because cryptographically, you need the user to participate in the signature generation. Okay, so this is the concept.
And Omar, just briefly, you mentioning zero trust, obviously through the presentation, as kind of like the main kind of ethos, if you will, of crypto, of Web3, and of what you guys are building. And then there's also like zero knowledge proofs. And maybe we can kind of get into like some of the more technicals as to how it works. But I was curious, just kind of like how you guys are using ZK to make this possible, if at all.
Yeah, so first of all, it's connected to the MPC. And maybe I will explain first of all what it means, MPC. I know that many people are familiar with MPC, maybe from Stacks or Thorchain or from solutions like Fireblocks. But MPC in general, what it means means multi-party computations. It means that different parties can generate, they can run computation together without sharing their secret information. And you can use that to sign transactions, right? So instead of having just a private key, you can have secret shares between the parties that participates in that MPC. And then whenever they want to sign a transaction, they do it together without sharing their secret share. So you create a signature, no one has to share their own secret share. And this is in general how it works for signatures, like in Fireblocks, in Thorchain, Stacks, chain abstraction today that nears us, right? And the two problems that you have a few problems with the existing protocols that all of them are using. Is first of all scalability. It's really hard to scale those protocols, especially when it comes to ECDSA signatures, which NOR and EDDSA it's easier, but with ECDSA it's the hardest, and you can go over around 20-30 parties. And this is why, for example, with Thorchain we have a max of 20 parties. It's really, really hard to make it decentralized. With Schnorr, it's a bit better, but still, in terms of scalability, everything is very hard. And in 2PC MPC, the new protocol that we created, we can scale it to thousands of participants and still to have amazing performance, right? So we are the first one to do that, to create this protocol. And the second part is also to include the user. So let's say that you say you need 2/3 of the validators to generate the transaction. But whenever you do that, you don't include the user. It means, again, the validators, they become the moat. And if you get access to the castle, you can generate transactions freely to any user, to any asset. You can steal everything. You can do whatever you want. In 2PC MPC, for the first time, it's not enough. You need 2/3 of the validators, and it can be thousands of validators, but still you need the user, right? So for every user, you need and when I say user, it can be abstracted, right? It's not something that the user has to do, right? It can be abstracted as part of the protocol. But the concept is that without having the consent from the user, you can't generate a transaction. So you're making sure that this protocol is zero trust all the time. So you can think about it as go ahead, Robbie, sorry.
No, sorry, please finish.
And so you can think about it as what we did was to use the existing mechanism that we have in blockchain for making it zero trust, which is the user signatures, right? And on top of that, we created a new layer where you can create logic between the different networks, but at the same time keep the user in the loop, right? So the user knows that there is no way to make transactions without them and steal the assets. So this is the concept.
And so in the current format of how we interact with blockchains, I open up my wallet and I sign a transaction, and that's my public key. That's signing I press confirm, and it signs that my private key wants to do this thing. My wallet, I instruct my wallet, I confirm the transaction. And so when I'm signing that transaction, what you're saying is that in traditional MPC, I need a counterpart to sign that transaction. And then I have two, and I have the validators to sign. I have my signature, and then it executes the transaction. In 2PC MPC, well, I guess that's the part I don't understand, because when we interact with blockchains now, the user is submitting the transaction to the chain, and we're doing that by pressing confirm, and that signs the transactions. And so in the model of 2PC MPC, what is different about the user flow of signing transactions?
Yeah, so it's a good question. So whenever what you explain about MPC, when you use it as a user, you're correct. This is whenever you use something like Fireblocks, right? Or you have also retail apps for MPC, but this is when you use like centralized MPC, and then you do it, you sign together with Fireblocks, or you sign together with Zengo or any other of those solutions, right? But this is more of making a better security from the user perspective. What I'm talking about is from the protocol perspective. So let's say, for example, that you want to create a protocol, a swap protocol between BTC and ETH, right? How you do that? So for example, you use bridge, right? And that bridge might be implemented with MPC, right? For example, this is like, for example, with chain abstraction. So with chain abstraction, on here, you have, I think, between 5 to 10, I'm not sure what's the exact number, of nodes that participate in the MPC. And they generate transactions to all the chains, all the different chains, and this is how they create the chain abstraction. So you as user, you have to give the assets, you have to transfer the assets to the address of the nodes of the chain abstraction, right? So it means that you are not the owner anymore, right? You can't sign, it doesn't matter what you do, you have to trust that somebody will follow your action, right? So then if you want to swap, you do it, you swap it, but this is on the abstracted layer. But on the underlying layer, they can steal the asset, right? You have zero control over it. And that's the point. That's the concept, right? So from the user perspective, if I create a zero trust swap protocol, it means that the user will have to sign every time that you have to actually transfer the asset, right? So there is no way that in between somebody can steal the asset from you, right? So that's the difference. So you are part of those of those protocols that interact in different chains for the logic or for the value of the protocol, right? So that's the difference. Does it make sense?
Yeah, I guess my only hang up is that, like, you know, people have been trying to do atomic swaps for a really long time. And so if, you know, we go back all the way to like Shapeshift and Eric Voorhees in the beginning, you know, he was trying to do these atomic swaps. And I think what the issue was that we were, you know, someone would have to sign that I would send my, so let's say Bitcoin and ETH. That's probably the best atomic swap example. So let's say I have Bitcoin, you have ETH. I want to sign my Bitcoin, goes to you. On your side, you sign your ETH, goes to me. But unless those happen at the exact same time, we have to derive some consensus, right? And so, like, if I sign my Bitcoin and then it takes 3 or 4 or 5 seconds, you have my Bitcoin, but I don't have your ETH, right? So then bridges started to pop up, and they would do an escrow service. And then so I would sign my Bitcoin, and this is what you described. I would sign my Bitcoin to the escrow, you would sign your ETH to the escrow, and then they would release at the same time. And so, yes. Yeah, please.
Yeah, so what you're saying is a great example, and this is something that you can exactly solve with dWallets in a zero trust way, right? So the difference here is that the way that you do that, and by the way, we have a protocol that is building on us, and this is exactly what they're building, atomic swap between different assets, and their focus is on BTC, so you can swap BTC and ETH in a zero trust way. And the idea is that, let's say that we want to swap, right? You have your BTC, I have my ETH, and we want to swap. So each one of us has a dWallet, right? We sign future transaction to each other, not a full transaction, it's partial transaction. So it's just the side of the user from the MPC, and we both send it to dWallet network, right? Now dWallet network will wait. The logic that will be for dWallet network is that dWallet network will wait until it receives 2 partially signed transactions to each one of us, and dWallet network can also cryptographically verify that those are the correct transactions, right? That you didn't lie and you sign on a different transaction. So we know that you partially signed correctly and it's verifiable. And only then, once we have the both transactions, the wallet network will complete both transactions together, right? So it's a different way of thinking, right? It's those things were impossible in the past, right? Because you don't have a way to do that. And dWallet network and 2PC MPC is the first time that those stuff will be possible. The way, by the way, that you control the dWallet and you write the logic is using integration. So we integrate with other network, other smart contract network, and it can be L1s and L2s. By the way, we have that in the picture, in the diagram. And this is how we follow the logic, right? So we can write logic. Today we support Ethereum, we support SWI. We announced integration with the Monad and Avail, and we're going to announce many more very exciting L1s and L2s integrations. But that's the concept. So you can build the projects. For example, the team that is working on the atomic swap, they are doing that on SWI, right? So you can, from SWI, write the logic, you can write the smart contract, and you can decide what's the logic. So we say that the logic is that we wait for getting both transactions for both users, we validate that everything is correct, and only then we give the okay to complete the full two future transactions, right? Those capabilities weren't possible before, right? You don't have today any MPC protocols that enable something like that. You don't have any network that enables something like that, right? But this is exactly that removes this escrow that you need, right? Because if you have escrow, then it's not zero trust. Then you have castle and moat. You have to trust somebody, and the escrow, it's exactly that castle, right? If you get into the escrow, you can steal everything, and that's exactly the difference. So let's talk about a few examples, right? I think the very obvious solution is decentralized custody. So it's a solution to manage custody. It can be for institutions, for companies. We have, by the way, a team that is building that on SWI. The idea is that you can think about it like any other custody solution, but that it will be decentralized, will be built using dWallets. The second one is staking for native BTC, or it can be any asset, right? So you can think about it a universal eigenlayer that is not specific to one chain, and you can hold assets on any chain. And the idea is that me as the user, I hold 50% of the power, right, the consent. So this protocol, whenever protocol that builders will build, won't be able to steal the assets, right, the staked tokens. And this is super important for staking. We have the native BTC atomic swap, right? We talked about that. This is, I think, super exciting example, especially when we connected that to BTC, and we'll talk a bit more about Bitcoin L2s and how it all connected, right? We'll connect all of that because our solution is it's crucial for Bitcoin, especially for the security assumptions that we have in Bitcoin. But we have many, many examples of usage, things that you can use. You can use that for lending, right? So I can use all my BTC as collateral on my dWallet, right? I don't have to transfer. I don't have to escrow that, right? I don't have to deposit that in any protocol. I can just hold it in my dWallet. It will be locked with the future transaction for liquidation in case that you don't repay the loan, right? Very simple, very intuitive, and zero trust. Multi-chain NFT that you can borrow, you can lend, you can rent, right? It can be across different chains. So you can create a dWallet that holds NFTs in different chains. Ordinals marketplace, right? Think about today how hard it is to transfer ordinals. So instead of that, you can just create a dWallet and to transfer the dWallet, right? The dWallet itself is also transferable. So we create new capabilities that instead of transferring the ordinal itself and waiting forever, right, and having so many issues with doing that and cost and all of that, you can just play with the account that owns the ordinal. Also, we're right now doing running SWI Overflow, which is a global hackathon together with SWI. We're hosting the hackathon with them. And here, if people want to read more examples, so we have a document with more examples, more use cases. what you can do, what you can build with dWallets. This is more focused on SWI, but you can really do it in L2s. You can do it in any other L1s, right? So before I'll talk about Bitcoin L2, I just want to start from Rollups and how Rollups are connected to Zero Trust and in general, modular blockchain. So Rollups, they are Zero Trust. And why they are Zero Trust? It depends on the type of the rollup, right? If we're talking about ZK rollup or optimistic rollup. But in both cases, we have a way to verify that the user really signed every transaction. It can be an optimistic way that we trust somebody, but then we can dispute and everybody can say it's not correct. And with ZK, we have as part of the proof, the proof includes cryptographically, it includes that information, that the transactions were approved and verified, right? So in both cases, we have a very strong way to do that. And also because it's Zero Trust, the bridge, the connection between the L1 to L2 is also Zero Trust, right? So although in optimistic, we have to wait like a week, still it's Zero Trust. We know that if we waited for a week, it's not possible to steal the assets, right? There is no one that can steal the assets. Now, you have a question, Andy?
Yeah, I mean, I was gonna kind of get to this, and that I think that it's important to define what a rollup is as well, and explain how like these the ZK proofs work, like the validity proofs, or and kind of how fraud proofs work on optimistic rollups. Because yeah, as you're getting to the next slide, as we kind of come to the close, I think there's quite a bit of difference between L2, sidechains, and rollups in the Bitcoin space. And this PowerPoint being about Zero Trust, I think it's it's important to highlight what is and what's not.
I agree. So the thing about optimistic rollups is that we have the execution layer, and we can provide a fraud proof to the rollup, to the execution layer. Sorry, for example, if we do it on Ethereum, so we can submit that to Ethereum. And in that case, if somebody tried to lie and to publish the wrong state, we can fix that, right? And we keep it for a week, usually. That's the case, like in Arbitrum and Optimistic. Week, because that's the time that we can make sure that we did everything that's possible to validate. And after a week, if no one submitted a fraud proof, right, if there is no dispute, we can assume with a very high certainty that that's the correct state, and no one tried to compromise the state, right? With ZK, the way that we do it with ZK is that we create a proof for every block, right? So we have the sequencer that executes the blocks, right? And the sequencer generates the state, like what's the state after running the block. But with ZK, we also have a succinct proof that includes executing all the transactions and verifying the transactions, the user, the signature, all of that, right? So as part of that succinct proof, we can cryptographically, if we validate this proof, you can think about it like this proof includes verifying every transaction on every chain cryptographically. So it's like aggregation. It's not really aggregation, but just as an idea, you can think about it that way. And usually the way that it works with ZK rollups is that you have the last block, and they connect between the proofs, right? So you change the block from the last, so you change the state from the last block with the last state, right? And you connect between the proofs. And because you connect between the proofs, you can think about the last proof as a proof that includes only all the history, right? This is why ZK proofs are so powerful, right? And also why ZK rollups are very powerful. The problem with ZK rollups is the time, right? The performance. So it still takes a while. It's not that easy. Yeah, I know that with the top ones, it takes like a few hours. So it's not immediate, but once you have the proof, you know what is the final state, and no one can lie. But it's heavy, it takes time. An optimistic rollup, you don't have that problem. The problem is that it's optimistic, so you have to wait. And this is the way that you make sure that the security assumptions are met. So we're talking about rollups, L2s in general, not about Bitcoin. And here is when we connect that to Bitcoin L2s or sidechains, right? Some people say that Bitcoin L2s are actually sidechains, at least most of them, not all of them. There are a few that really trying to be L2s. But the problem in Bitcoin that it's super hard to do that because we don't have smart contracts, we can't execute whatever we want, everything is strict and limited. So to validate proofs on Bitcoin, if it's fraud proof or ZKproof, it's almost impossible. There are a few teams that are trying to find ways to do that. Let's see if they succeed. But most Bitcoin L2s, when they say that they built Bitcoin L2s, what actually they mean is that they are kind of a sidechain or they are roll-up on Ethereum or other chain with some kind of a bridge to Bitcoin. So you have a programmable BTC because you have a bridge, right? This bridge can be with the MPC, it can be with a very strong technology. But again, whenever we connect that, those solutions are castle and moat, right? Because we don't have that guarantee of L2. We don't have that guarantee of the connection between L1 to L2, like we have on Ethereum or Avail or other networks that give us this same security assumption. Here, because it's really, really hard to do that on Bitcoin, so many of those solutions, what they actually do is to create a rollup or a sidechain that have some way to connect with Bitcoin. It might be a very, very good technology, very good solution. But again, that's a moat, and we have the castle. And if we get into the castle, we control everything. And the way that we think about it, we believe that we get it. We get it that it's hard, right? It's hard to create a real Bitcoin L2 like we have on Ethereum. And people want ways to have a programmable BTC and to play with BTC and to use BTC, which that's all makes sense. And we also believe in this concept and in this vision. And this is why we think that dWallets are the solution to create those Bitcoin rollup sidechains, right, in a zero trust approach. Whenever we get from both worlds, right, we get a benefit of being zero trust, and we get this capability of programmability of the native asset, right, without worrying about compromising our asset. So this is really the way that we look on that. You have the native BTC, no bridging, no wrapping. You hold it directly. And you can use that for rollups. We have a few partnerships. I think Avail is the most interesting one, right? Because also you can create a Bitcoin rollup on Avail. And that Bitcoin rollup, although it won't be like L2 execution layer on Bitcoin, but it still will be zero trust. And we believe that it's important in general, but if you connect that to Bitcoin, it's even become much, much stronger because the concepts, the fundamentals of Web3 of security assumptions are much, much stronger in Bitcoin. I think people that got into the space through Bitcoin, they keep the same mentality, right? For example, we have the phrase "not your keys, not your coins," right? It's very Bitcoin oriented, and it's correct, right? If you use a bridge, then it's not your keys and it's not your coins, right? They're totally correct. Also in Bitcoin, you have a lot of institutions, and if you want to have institutions, you have a way to hold the native asset and to program the native asset, and not to use a derivative or any other representation of the asset, which can cause issues from regulatory or compliance issues. And also you have in certain areas, right, it's not everywhere, but also you have tax consequences, right? Because In some places, whenever you use a wrapped asset, it's like you get a new token, so you like swap different tokens from the perspective of some tax authorities, and then you have to pay tax even for that action. So if you can eliminate that, you solve so many issues, right? You always keep the native asset, and that's it. Very simple. And yeah, I think we're done. Do you have questions?
Yeah, that was great. So this is the last slide here. Okay, so I do have a couple questions. I mean, first off, thank you so much for coming on. This was phenomenal, and it was very different from the Bitcoin and Beyond presentations that we've had so far in the series. We've heard a lot from some of the Bitcoin projects out there that are building L2s. Most of them are sidechains at the moment. Some of them are more open about being a sidechain in the moment, and the roadmap to progressive decentralization. Most of them have BitVM as like a pretty important piece of their roadmap. And the more honest ones and even the dishonest ones basically recognize they're sidechains now. But in order for them to become rollups, and I'm just going to revert back to this slide because these are zero trust execution layers. And so I'm going to make the differentiation. Rollups are zero trust. Sidechains and L2s are not zero trust. They're castle and moat. And so most of the Bitcoin L2s right now are castle and moat, but with BitVM, they would become rollups because BitVM is supposedly a trustless bridge with exceptions and complications. So I'm curious, does in your perspective, does BitVM preserve the zero trust properties that you feel are important to make something zero trust and keep native assets? Does BitVM get there?
So I'm more familiar with the second version, the BitVM 2, which is more with the ZK stuff. So with the BitVM 2, yeah, like in theory, my difficulty with the solution is if it's practical, right? That's really the issue. And maybe it's practical. Maybe we need to have some upgrades for Bitcoin to make it really practical, right? But I feel like it's not mature yet. It's not. I think like the project and the team, everything seems really good, like the right approach. And this is what I will really look at as rollup, right? A real rollup. But at the end of the day, it's really, really hard to do that with the Bitcoin, just because of the design, because of the capabilities, because of what you have with Bitcoin. And this is also why it's part of the roadmap of those many projects, and it makes sense. So the first thing that I would suggest is to use dWallet, right, and make it zero trust. So yeah, it's okay that it's a sidechain, but why not to have a zero trust sidechain instead of having a castle and moat sidechain? And from the second perspective, I would love to see BitVM become very successful. At the end of the day, the goal of dWallet is to connect between everything. So we are working with L1s and L2s, and we would love to see real rollups on Bitcoin. But I feel like it's more of a future solution, and we'll see later on. But the direction is the right direction.
Awesome. Okay. That's my only question. Thank you so much for coming on. It was an absolute pleasure. And yeah, very much looking forward to the integration of dWallet into some of these networks.
Sounds great. Thank you, Robbie. Thank you, Andy.